In this video, we're going to examine how we use the elimination method for solving linear systems. We have two equations, two unknowns, and our goal is to find out what those two unknowns are. So remember, our whole method for solving is to create a situation where we eliminate one set of the variables. So what we can do is rewrite each of these equations. So the first one, 3x plus 2y equals 4. Now we look at the second equation, we have a negative sign here. So if we can make this a 2 somehow, we'll be able to eliminate the y's. How we do that is we multiply by 2 on both sides of the equation. So what we do to one side, we have to do to the other. Now you have to realize this is a distribute here. So what we have is 2x minus 2y equals 6. Now we can add up the two equations, collect our like terms for x's. The y's become a 0 pair, and 6 plus 4 is 10. Divide by 5, divide by 5, x is equal to 2. Use x equals 2 in any of the equations. Let's just take the second equation and plug in the 2. So y is equal to, and we've got a 3 on the one side, so we'll subtract 3 both sides. So we have y is equal to minus 1. The solution is 2 comma negative 1. If we were to graph these two equations, those two lines would intersect at the point 2 comma negative 1. Second example is we have y's that could possibly become 0 pairs, but we have 2 pluses. So when we change one of the equations, we need to make one of the y's a negative. So let's multiply both sides by a negative 2. What we have then is negative 4x minus 2y equals minus 6. And we'll keep 3x plus 2y equals 6. We have a negative x and a 0 pair equals 0. So x is equal to 0. We'll use x equals 0 in any equation. We'll take the second one. Plug in the x value. 2y equals 6. Divide by 2 both sides. So y is equal to 3. The coordinate would be 0, 3. Now we can verify or check that that point works by plugging into the original equation. So we'll use the other equation, 2x plus y equals 3. Let's check to see if an x value of 0 and a y value of 3 will work. So 2 comma 0 plus 3, does that equal 3? 3 does in fact equal 3, so it does work. If we check with the second equation, 3x plus 2y equals 6, 3 bracket 0 plus 2 times 3 equals 6. Does it equal 6? And in fact, yes it does. When you solve these two systems here, first of all, this positive 7 needs to move to the right side. We're left with x minus 3y equals negative 7, and we'll keep the second equation, 3x minus 2y equals negative 7. Now, when we rewrite, we can choose to eliminate the x's by multiplying by negative 3. We're left with negative 3x plus 9y equals 21, and 3x minus 2y equals minus 7 stays. And we'll add the two equations. The 0 pair happens here. 7y is equal to 14. Divide by 7. Divide by 7, y is equal to 2. Let's use y equals 2 in the second equation to solve for x. 3x minus 4 equals minus 7. 3x equals minus 3. Divide by 3. So x is equal to negative 1. And the point is negative 1, comma 2. Let's perform a check. X minus 3y plus 7 equals 0. Plugging in the x and the y value. Negative 1 minus 3 bracket 2 plus 7. Does that equal 0? Minus 1 minus 6 plus 7. Does that equal 0? And in fact, 0 does equal 0. The fourth and final example for this video is we have a situation where we don't have negative and a positive, and we also don't have one variable a multiple of another, but we can use the fact that 2 times 3 is 6. Let's eliminate the x's. So we're left with negative 6x minus 9y equals, now 48 times negative 3 is negative 144. Now 2 times 3x is 6x. 2 times 2y is 4y. 2 times 42 is 84. Let's add up. Here's our zero pair. So negative 9y combined with positive 4y will give negative 5y. And negative 144 combined with positive 84 will give a negative 60. So now we're going to divide by negative 5. And y is equal to positive 12. Now we'll use positive 12 for the y value in the first equation. Plug in 2x plus 3 bracket 12 equals 48. 2x plus 36 equals 48. Circle the chunk with the x and subtract 36 both sides. We have 12 equals 2x. Divide by 2. X is equal to 6. The solution would be 6, comma 12. We'll take the original 2x plus 3y equals 48, and we'll plug in the 6 along with the 12 and check if it's 48. 12 plus 36, does that equal 48? And yes, in fact, 48 does equal 48. I think we better stop here and start a new video.